All right, in this video, we're going to talk and do an example of exception handling. We're going to do that same example that we were talking about in the previous video. So what we've got is this program here, and it says it prompts the user to enter an integer from 1 to 9 inclusive. So 1, 2, 3, 4, 5, 6, 7, 8, or 9. And then we just print the number back to the user. So, and it works fine if the user is perfect and enters correct input, it works great. But if the user enters some letters or a decimal number, it's going to crash. And what we want to do is prevent that from happening. So you can see right here we've got line 1 is where the exception was thrown. And it's a value error, invalid literal for int with base 10 ASDF. So I entered ASDF, which is fine for this input part, but what it did next was try to convert that to an int, and that doesn't work very well. Okay, so what I want to do is to use a try and except block to prevent that from happening. So, okay, so what I would do then is to put this part that's causing an issue in the try part. Remember, the try part is basically your way of telling Python, hey, Python, just make sure that, and watch this line to see if any exceptions are thrown. And then down below, right, I would put an except block, and the error that we had was value error, right? So you can see that down the message that we had. And again, this is basically the plan. Hey, you're telling Python, look, if a value error is thrown on these statements that you're watching up here, then this is the code that I want you to immediately jump to, okay? All right, and so what we want to do then is to give a message to the user, print, and we'll do something like this, number is not an integer. And then we will just quit the program for right now. Now, there's lots of different types of things that you could do if an exception is thrown, right? And one of them is just to quit out of the program. It's not the best option, but it's right now the easiest option for us to take. So we'll just take that. And then later on, we'll change this and make it a little bit better. All right, remember what's going to happen is if you don't put quit right here, then the program will keep running. When sometimes you want it to keep running, and in fact, most of the times you want to do, but right here, just, we're kind of taking the easy way out and just quitting out of the program. Hey, something went wrong, I'm out, So if you're going to do that, then you need to put quit right here. I'm not saying that you need to do that every time, but just for right now, that's what we'll do. All right, so when we try to run that, we'll see that that's going to cause another error. So if I enter 7, let's say, everything runs fine like it did before, right? That's because no exception was thrown right here. That means it jumps down to this after the except into this line and printed you entered number. So that works perfectly. But we can see if we enter some bad input, so if I enter like 4.56, which is not an integer, that's going to cause this value error to be thrown. And in the process, right, something else bad is going to happen. So you can see I got that value error like I did before, 4.56. You can see during handling of the above exception. So it was trying to handle it. It jumped down here to line 4. And then another exception was thrown there. And that is that this variable number is not defined, right? Because this statement up here never completed. Okay? So to prevent that from happening, what I'm going to do is to split this into two parts. Here we were getting the input, and then we were converting it to an int. So the part that's really messing things up is this int part right here, not the input part. So I'm going to define another variable called number string, and that's going to get the input. Okay, and then I'm going to define the variable number to be int and then number string. So I'm going to separate the input part from the conversion part. That way, is even if this fails, right, we'll still have the input as a string up here. And so in this message, we can tell the user what they typed in, right, that was not good, okay? And that's a lot better than how we had it before. So enter an integer from 1 to 9 inclusive. So if I enter ASDF, right, you can see ASDF is not an integer, terminating program. So at least they get to see what it was that caused the issue, okay? And that's good. We're giving them some information that could potentially be useful to them, okay? All right, next up is another issue. So we've taken care of that problem, right? If the user enters a decimal number or some letters, right, they get a message and it's terminating the program and everything. It's not throwing the exception, so it's a cleaner exit than the program just crashing. So the other thing, though, is we wanted numbers from 1 to 9 inclusive, right? And so if I enter 23, we'll see that that's not going to crash the program. That's perfectly fine as far as it's an int value, so this conversion is going to go fine. But it's really not from 1 to 9. We also want it to be from 1 to 9, okay? So what we're going to do then is, to prevent that from happening, right, is to add another line in there. So if number is less than 1 or number is greater than 9, then what we're going to do is, again, give the user some information here, just using this simple if statement. So what we would say is number is not in the correct range, and then terminating program. Okay. Okay. And I forgot to quit, so it's not going to help. So you can see that I entered 23. I did get that message, right, that it was not in the correct range, terminated program. But it still continued on down here, which I don't want it to do. So in order to do that, I'll do quit right here. So now you can see it says 45 is not in the correct range, and we are terminating the program. Okay, so far so good on that. So you can see now we have some error handling going on. One we are doing with an error right here, and that one really, there's probably another way we could do that without the try and accept thing. In fact, yes, there certainly is, but here I needed to give you an example of how to use the try and accept thing there. But this one, notice this validation part we handled with just a simple if statement here. Okay. Now, the one thing I would like to do here is, it's kind of annoying that it doesn't keep asking the user, to keep going in there. So that's what I wanted to do. Instead of terminating the program here, I just want to keep asking them to enter an integer in the right range right here, or with the right properties. So what I'm going to do is just to put this in a loop, and I'm going to do while true. So normally that would get stuck in an infinite loop, right? Because this condition always evaluates to true. So it would keep repeating this over and over again. And so this is the block that I want to repeat. I'll need to indent that. So if I highlight that and press tab, then it will indent that over. So I can do it like that. So that will repeat this block over and over again. So what I want to do is get rid of terminating program here and here, and get rid of quit here and here. All right, and now it should keep asking the user. So here you can see I'm entering a bunch of bad input. It will keep on asking me, right? After this except block, if that goes wrong or if this one goes wrong, it will bounce up here to check the condition, right, while true. So it will keep going over and over again. But also we're stuck in an infinite loop, right? Even if I enter correctly, right, it still keeps on going, which that's not what I want. If the user enters valid input, then this should stop. That's what I want. So hit stop button right here. And then how we'll exit this loop is what we'll do is at the very end of the try block, we'll hit break. We'll put a break thing in there. So if something goes wrong, the user doesn't enter bad input, it's going to immediately jump, right, to this value error, and then it's going to keep going over here. And the one thing we'll need to do right here, if the user enters a valid integer, but it doesn't it's not in the correct range, right, then it will also break here. So we can see that if I hit do 45, that's not in the correct range, right? But you can still see it broke right there. So that's because it keeps going after this if statement. So if we put a continue statement in there, that will prevent that happening. It will skip the rest of the loop and bounce back up here and keep going. So if I enter some larger number, right, it will keep going until I enter a number in the correct range, okay? All right, so that's a lot better than what we had at the beginning. Okay, in the next video, what we'll do is we will check this range condition in a different way, also using exceptions. But really, this is going to kind of be the preferred way. I just need to illustrate one other concept to you about these exceptions.